Bismillahirrahmanirrahim. Assalamualaikum warahmatullahi wabarakatuh. So tonight we'll be explaining one of the subtopic in our last topic pipeline about the pipeline hazard. So as we know, the performance gain from using pipelining occurs because we can start execution of a new instruction each clock cycle. In a real implementation, this is not always possible. Another important note is that in a pipeline processor, a particular instruction still takes at least as long to execute a non-pipeline. Next is the pipeline hazard prevent the execution of the next instruction during the appropriate clock cycle. So tonight I will be explaining about the pipeline hazard that will prevent the execution of the next instruction during appropriate clock cycle. So there are three types of hazard in a pipeline. First is there are resource hazard, data hazard, and the control hazard. The resource hazard are created when the data pathway in the pipeline cannot support all of the overlap instruction in the pipeline. The data hazard is when there is an instruction in the pipeline that affects the result of another instruction in the pipeline. For example, is if the instruction 1 is A plus B equal to C. The instruction of the second instruction is D plus E equal to A. So the first instruction is dependent to the second instruction. So this will cause the data hazard. So the third is the control hazard. The PC cause this due to the pipeline of branches and other instructions that change the PC. Next, I will talk about risc. What is risc? Risc is a computer based on a processor or processor design to perform a limited set of operations extremely quick. So risc is a computer design or a processor architecture that designed to perform a limited set of operation extremely quickly. It is contradict to cisc. The cisc I will be explain later. So the risc is the design of processor that focus on complete task quickly, extremely quick. So what is the key feature of risc is first is limited and simple instruction set. Second is large number of general purpose registers. Third is use of compiler technology to optimize register use. Fourth is emphasis on optimizing the instruction pipeline. So what is the driving force? So next, just now I talk about cisc. Now I will talk about the driving force for cisc. So driving force for cisc is the software cost part exceed hardware cost. Second is the increasingly complex high-level language that leads to the large instruction sets, more addressing modes, and hardware implementation of high-level language statements. So the intention of cisc is to generate powerful high-level language, express algorithm more precisely, and compiler to take care about unwanted issues, support structure programming. The second is compiler writing. Third is improve execution efficiency, and then support more complex high-level language. What is risc characteristic? First is one instruction per cycle. Then register to register operations. Third is few simple addressing modes. Then few simple instruction formats. Hardwired design, no microcodes. fixed instruction format and more compile time or effort. Next is, just now I forgot to tell about what is cisc. I have tell about the risc. Now I tell about cisc. Cisc is a complex instruction set computing. So we call it CISC, complex instruction set computing. Is also a processor design where single instructions can execute several load operations such as load from memory, arithmetic operation, and memory store, or are capable of multi-step operation. Or we can just simple way to tell about cisc is a processor design which is capable of multi-step operation or addressing mode with single instruction. So risc vs cisc. So risc vs cisc. First is cisc is emphasis on hardware, but risc emphasize on software. Second is cisc includes multi-clock complex instruction, but risc only single clock reduce instruction only. Cisc memory to memory, but risc register to register. And then cisc small code size, high cycles per second, but risc is low cycles per second and large code size. So that's all from me. Thank you. Oh, kau gerak saya. Kasi 6 minit semua.
Dah. Hi friends, so in this video we are going to discuss about pipeline hazard. So pipeline hazard means it's a difficulty in the pipelining concept. So pipelining is having more advantage in the regarding so pipelining concept is having more advantage in the improving the performance of the processor. So in same time it have some difficulties. So we'll discuss here. So there are three types of hazards are there related to pipelining concept. One is the resource hazard, and second one is the data hazard, and third one is the control hazard. So resource hazard always may be called as a structural hazard. We'll discuss here. So example, you just consider two instructions. If these two instructions are requires the resource 1 at a time, that is a instruction 1 and instruction 2 requires the resource 1 for the execution. So when the resource 1 will be released by the instruction 1, if the resource 1 is accessed by instruction 1, so end of T5 only the resource 1 will be released by the instruction 1. But instruction 2 is required at a time of T2 itself, it's required. So this is the resource complexity between resource access complexity between instruction 1 and 2. So this is called resource hazard. And second one is the data hazard. You just consider add A comma B and sub A comma C. So if these two are the instructions, that is instruction 1 and 2, so when the data will be released by the first instruction, that is A. So A's data will be released only after T5 seconds, but instruction 2, that is a subtraction instruction, may request the data at the time of T2. So this is the complexity related instruction 1 and 2 regarding the data point. Okay, so this is called data hazard. Okay, and third one is the control hazard. If the branch instructions are there, so branch prediction is there required for the particular instruction execution. If the branch prediction is wrong, instructions execution will be stopped. So this is related to control hazard. So these are the three types of hazards related to pipelining concept. One is a resource hazard, and second one is a data hazard, and third one is a control hazard. Thank you.
In this presentation, we will be discussing some of the most prominent differences between the two common processor designs, complex instruction set computing, or cisc, and reduced instruction set computing, or risc. A topic of much historical debate, these two designs differ vastly in structure, methods of execution, as well as usability. In order to understand the differences between cisc and risc processors, we will cover the basics of what a processor is and what it does. A processor, also known as the Central Processing Unit, or CPU for short, is where most of the calculations are processed. A CPU does 4 primary tasks: fetching, decoding, executing, and write back. The two types of CPU architectures we will be discussing, cisc and risc, both accomplish primary processor jobs, such as decoding and executing. However, their approaches to doing so differ. In general, risc has an assembly language that is designed so that each task is broken down into very simple instructions that are each executed once per clock cycle. Cisc executes larger and more complex assembly instructions at a time. Risc instructions are highly efficient, but due to their simplicity, they result in many more lines of code, whereas with cisc, one instruction may equate to several risc instructions. This results in simpler code at the cost of efficiency. These are not the only differences between the two architectures. As stated earlier, cisc architecture contains more complex assembly code, while risc code is simpler. As such, cisc's minimal code is more programmer-friendly, but risc tends to be more machine-oriented as the code is longer. Due to the nature of their architectures, cisc requires intricate hardware to compensate for its complex instructions, while risc emphasizes on software due to the increased length of the code. Since risc is simple, each line of assembly takes 1 clock cycle to execute, while cisc assembly lines may take multiple cycles. Take, for example, the process of multiplying two numbers together, which requires register loading, multiplying, and storing the resulting operand. A risc processor needs you to list all of these instructions one by one, whereas a cisc processor can use the mult instruction to do this all at once. Risc-based processors are very common today, especially in mobile devices due to the power efficiency that they offer. However, most laptops use the cisc-based x86 platform, since most laptops use Intel processors. Since cisc coding is also more user-friendly, this makes x86 a very prevalent cisc-based design. One interesting fact about the x86 platform is that it uses microcode, a lower-level machine code, to take advantage of some of the efficiencies that the risc-based designs offer. The use of risc and cisc processors in industry are dependent on associated costs. Early on, RAM was quite expensive, and utilizing less RAM was preferred. By designing complicated processors, a single line of code could translate to multiple instructions. This reduced the amount of RAM usage. However, multiple clock cycles resulted in heavy power usage. The risc architecture seemed like a viable solution to this. It used more registers within the CPU, and thus reduced the use of RAM. The Spark processor is an example of this early success of the risc architecture. Until the early 1990s, it seemed as though risc would become the industry norm. However, cisc processor manufacturers started implementing risc-like features. Many modern processors today consist of the cisc-risc hybrid. Yet risc processors, such as ARM, are still common today. Their simple structure allows them to be diversely integrated and also power efficient, which is of paramount importance to today's mobile technologies. To summarize, the main difference between cisc and risc architectures are their approaches to coding. Cisc assembly language is more complicated than risc assembly language, while risc assembly language relies on simplicity. While cisc software is more compressed than risc, the trade-off is that cisc processors contain more complicated parts to accommodate the complicated assembly language. Today, many computers use cisc or cisc-risc processors, such as x86, as cisc is considered more programmer-friendly, while smaller devices, such as phones, use risc processors to conserve power. Thanks for watching our presentation of cisc versus risc.